Okay, I hear the recording in progress. So let me share the screen. Okay, we are not going to have very much of a meeting at all today. I'll talk about the quiz. Maybe do one more problem from 11.11, and then I'll let you have the rest of the time working on the quiz. Okay, so we're down to our last section, 11.11. And then remaining calendar, we're practically done. So we're aiming for the test on Thursday the 9th again. A lot of repetition, but again, this is just a safeguard that everybody knows the rules and people don't have an excuse not to know the rules, I guess. Okay, so exam 5, Thursday the 9th. You will turn in all of this homework. You say, what's going to happen Friday the 10th? Well, basically nothing. It'll just be a glorified office hour. You can come or not. I don't have to record anything, I don't think. All right, so you can come and join regular Zoom class as an office hour. I'll still have the regular office hours if you want to join me for that, but it's optional. Then the week after is final exam week. We don't meet on Monday. We don't meet on Tuesday. We don't meet on Wednesday. We don't meet on Thursday. Our next formal meeting is Friday the 17th for the final exam, 8:10 to 10:40. Just study off the old exams. Most likely scenario I'm thinking of is, say, 3 questions per exam. So I'll take 3 questions from the first test, and then 3 from the second, and then 3 from the third, 3 from the fourth, and 3 from the fifth, which we haven't had yet, and cobble that together for the final exam. Final exam, you get 2.5 hours, as you can see. And you're allowed 5 cheat sheets for the final exam, 1 for each chapter. You don't have to reinvent the wheel. If you already have the old formula sheets, just bring them in. If you forgot it, you threw it away, you can reconstruct it. If you want to add something to it, you may. Like you may have had exam 2, let's say, and say, oh, I wish I had put this formula down. Go back and put it in now. That's allowed. And here are my office hours during finals week. Okay, no office hours on Monday, but Tuesday, Wednesday, Thursday, 8:10 to 10. The regular Zoom session, 14th, 15th, 16th. For the final exam, use the same Zoom link. So we don't have to change Zoom links all the way throughout. And remember to bring yourself a piece of polar graph paper, just in case. I'm not promising you it, but in case I ask you to do a polar graph, you want to be able to have the polar graph paper handy also. Okay, so we're just about at the end, folks. Only 1 week left, as it were. And my suggestion for studying is do 1 test a day. So Friday, go back and review the first test. And then the following week, Monday, Tuesday, Wednesday, Thursday, exam 2, 3, 4, 5. You don't have to follow that. Of course, if you want to go back and do more, you can. But I would say as a minimum, do 1 test a day. Go back and review test 1, Friday the 10th. Then during finals week, Monday, Tuesday, Wednesday, Thursday, test 2, 3, 4, and 5. And I might send you something on Canvas announcements to that effect also. Okay, so just go back over the solutions. The solutions are the day after the exam, as you know. So look at the video for the first test. That would have been Saturday, September 4th, right? Then exam 2, look on Saturday, the 25th of September. Exam 3, Saturday, the 16th of October. Exam 4 would be Friday, the 30th of October. And exam 5 we haven't done yet, but I'll give that video to you Friday the 10th. Okay? And then you'll know how to study for the final exam. All right. So that's that. Anybody want to ask a quick question right now? Who's here about that? All right, so let's get going with the quiz. So be ready to take a picture on your cell phone, do a screenshot, or just watch the video later. Spend quite a bit of time talking about the quiz. Okay, so here we go. 4 questions. Do it 11:59 p.m. tonight, as usual. Open everything, but you must do it the way we did it in class, I suppose. Okay, number 1, find a power series representation for the function and determine the radius of convergence. F of x is x squared inverse tangent of x to the 4th. For the radius of convergence for number 1 and number 2, a hint is that it's fairly easy, I think. It's standard. Both of the derivations were from a geometric series. Okay, and what do you recall about convergence or divergence of a geometric series? Okay. Now, you have the formula for inverse tangent on that one page, right? I'm helping you guys out even more. Page 768, inverse tangent, there it is, right? I mean, who could ask for anything more? I'm helping you cheat on the quiz, so to speak. I'm giving you the answers. Okay, now, just like any other function, in place of x, replace it with x to the 4th. So in that expansion that I just showed you, erase x, put parentheses, x to the 4th everywhere. And then just multiply by x squared. Okay, and don't forget, you put at least 4 terms, put plus dot, 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 and that's about it. Okay. The nice thing about this, again, is you're going to get an answer that looks like a polynomial, an infinite polynomial, but nonetheless a polynomial. Very easy to differentiate, very easy to integrate. This is very clumsy to do anything, right? Okay, number 2. That looks like a geometric series. Integral of x over 1 plus x to the 5th. Back in our integration chapter at the beginning of the class, we didn't know how to do this. We can do it with infinite series. Okay, so a hint is make this look like a over 1 minus r. You say it's a plus. Well, you know plus is minus minus. So make it x over 1 minus a negative x to the 5th. And then it's a geometric series. And again, that should be a hint for a geometric series. What do you know about radius of convergence for a geometric series? So write this as an infinite geometric series. The formula is a over 1 minus r. I'll even write it for you. I'm giving you more. A over 1 minus r. That's a plus, but you can make it a minus minus. So x over 1 minus a negative x to the 5th. Okay, and once again, the usual ground rules, write down at least 4 terms. Okay, then you integrate term by term. And how do you do a c? We'll put the c in the front. C plus blah, 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 blah. Okay. Number 3. There's e to the x, right? In the formula, everywhere you see x, replace it with 4x. Everywhere you see x, replace it with 2x. So you get this power series for this, power series for this, and then just subtract. I'll give you an even bigger hint. For this one, you have to put at least 5 series for both. 5 terms for each. How come? Because the first term is going to drop out. For both of them, the first term is 1. So when you subtract, the 1s will drop out, and then your final answer has the requisite 4 terms, right? So write down 5 terms of this, write down 5 terms of this, and then subtract. You'll see the 1s drop out. And so the first thing you'll have is blah, 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 x, and then blah, 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 x squared, and then blah, 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 x cubed, and blah, 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 x to the 4th, and then plus dot, dot, dot. Okay. Number 4 is almost like 58 that I did the other day, didn't I? Look at 58. Integral from 0 to 1, sine of x to the 4th dx, 4 decimal places. The only difference is this is cosine. So do the exact same thing, follow the exact same format. Look at what we did for sine of x to the 4th dx. It's also from 0 to 1 to 4 decimal places. Okay, so you write the power series expansion for cosine x to the 4th. Write down at least 4 terms. 4 terms should be good. Then you integrate, plug in 0 to 1. You'll have an alternating series. which means the series will converge by the alternating series test. And then if you stop anywhere, the error is no more than the next term. So you have to go out far enough to get something to within 10 to the minus 4, right? So once you get a term that's smaller than 1 in 10,000, you can stop, just add up all the terms before that, and give your answer to 4 decimal places. Okay, so I'm kind of giving you lots of hints as to what to do for the quiz. Okay. All right, so if anybody wants to ask a question that's here about the quiz, you may. Otherwise, I'll let this go. I will lecture a very small amount of time and then let you work on the quiz. And move this over a little bit more just in case my face, sometimes I know in a video, my face blocks part of the question that's there. Okay, so that should be good enough. All right, so due at 11:59 p.m. tonight. That should take care of that. I will lecture a very short time. Okay. In fact, I only had one problem to do. 15. I still have Monday, Tuesday, Wednesday to finish up the rest. Okay, so last time I did a star problem. Let me do an actual problem. 15, a real problem. F of x equals x to the 2/3. And even looking at this is so clumsy, right? Having a fractional exponent. It's almost like, can I cheat and replace it with a polynomial? The answer is yes. You say, well, that's not fair. Yeah, but we can get a bound of the error in doing that. Okay, we're centered at a equals 1, n equals 3, third degree polynomial. X is between 0.8 and 1.2. So if I'm between 0.8 and 1.2, what's the best cubic approximation? N equals 4, what's the best quartic, fourth degree? Second degree, what's the best parabola, right? 18, what's the best linear function? It's linear, and so on. Okay, and my system is asking me to reboot. I'm going to make it snooze for 15 minutes. So I have to finish within 15 minutes anyway, I guess. So, yeah. My system wants to reboot. What's the nearest second degree, third degree, fifth degree, and so on. Okay, so I can't go long after all because the system's making me reboot. So I definitely have to quit soon. Okay, so f of x is x to the 2/3, centered at a equals 1, n equals 3. So automatically, I already know before I start, ignore the red. It's going to be, since it's centered at 1, x minus 1 to the 0 over 0 factorial. Yes, that's the same as 1. That's the same as 1. But in terms of memorizing this, once I have this, the rest is easy. It's x minus 1 to the 1 over 1 factorial, x minus 1 squared over 2 factorial, x minus 1 cubed over 3 factorial. Okay. I don't need the dot, dot, dot because they're asking specifically for a polynomial. Okay, so the e exponent and the f part are predetermined right back up here. Even without giving you the function, they don't even give you the function. Just this information alone tells me it's going to be x minus 1, and I keep going to the third derivative exponent factorial. So already set in stone, x minus 1 to the 0 over 0 factorial, 1, 2, 3 factorial. Okay, now what about the stuff in red? That's where the derivatives come in. Okay, so the function is x to the 2/3. F prime is 2/3 x to the negative 1/3. F double prime is negative 2/9 x to the negative 4/3. F triple prime is 8 over 27 x to the negative 7/3. Okay, and this is all I need if I were just asking for T3, the third Taylor polynomial. However, now we're asking for the error, possible error involved. So for the possible error, I need the fourth derivative, exponent, and factorial. So the fourth derivative is negative 56 over 81 x to the negative 10/3. Okay, now I plug in 1. Now 1 raised to anything is 1. So when I plug in, it's basically the coefficients. So that's 1. Plug in 1, 1 to anything is 1. So 2/3, negative 2/9, 8 over 27. Okay, we plug in 1 to all of these. It doesn't matter how funny the exponent is. It's going to be 1. All right, so these become the D part. Again, the E and the F in black are predetermined. The red stuff is what I put in. So 1 goes here, 2/3 goes here, -2/9 goes here, 8/27 comes here. Just clean it up. That's 1. 2/3 x minus 1. These two are usually pretty easy. This one's a little bit harder, and this one's the hardest. So by the time you do this one, you're glad you only have to do 4 terms quite often. Okay, let's see. That 2 is going to cancel that 2. So -1/9 x minus 1 squared plus 27 times 6. If you reduce the fraction, it's 4/81. You can take my word for it. That's just arithmetic. 27 times 6. 8 and 6 are both divisible by 2. Take out the 2. 4/3 times 27. So 4/81 x minus 1 cubed. Okay, so if you force me to replace this thing with a cubic polynomial, what's the best cubic polynomial approximation to the function near a equals 1? It's this thing. Okay. Now the argument might be, well, that's not fair. This is not the same as this. That's right. Okay. But can we find a tolerance? How bad is the error if I'm between 0.8 and 1.2? Okay, so now for the new stuff. Okay, so notation, absolute value of R3 of x, the remainder, if I stop at the third derivative exponent factorial. Okay, so that's what's meant by the absolute value of the remainder. I go to the fourth derivative exponent factorial. I just did the fourth derivative. Okay. So fourth derivative exponent factorial between 0.8 and 1.2. Okay, in absolute value. Absolute value. Okay. Now, x at a -10/3 means put x to the positive 10/3 in the bottom of absolute value, so I can drop the negative. Okay, and the game we play again is pick x between 0.8 and 1.2, which maximizes this quantity. Separately, pick x between 0.8 and 1.2 to maximize this quantity. And you don't have to talk about maximizing this quantity. 4 factorial is set at 4 factorial, which is 24. Okay, I dropped the negative because it's in bars. And once again, by the reciprocal rule, since this x thing is in the bottom, this quantity is the biggest when I pick the smallest number. We talked about that before, right? So I plug in 0.8. Okay, again, by the reciprocal rule, to make this quantity the biggest, x is in the denominator, I take the smallest number here, 0.8 to the 10/3. Okay, then separately, what number between 0.8 and 1.2 would maximize this? You actually have a tie. You could pick either extreme. Either 0.8 or 1.2 would give me either a plus or minus 0.2, right? And then you raise it to the fourth power, right? So I'll have that. So 56/81, 0.8 to the 10/3, 0.2 to the fourth power over 24. And that's what I want. Okay, and that's approximately 1 times 10 to the -4, 0.0001. Right, so what are we saying? If instead of using the actual function, I quote unquote cheat and pick this function, you say, well, they're not the same. That's correct. But the error is no more than 0.0001, 1 in what? 1 in 10,000 error. If I pick an x value between 0.8 and 1.2. Okay, so that's what it means. And we're centered at 1, which means if I plug in 1, they should be the same. Notice when you plug in 1 here, you get 1. When you plug in 1 here, you get 1. It's clearly 1 because if I plug in 1 here, here, and here, these are all 0, and so you have 1. So they exactly match at 1. And what if I pick something outside of 1? As long as I'm between 0.8 and 1.2, I'm within 0.0001 of the true solution. Okay. Again, the new formula, the last thing that we have for the semester, is the Taylor's inequality. Page 762. Remember, I replaced this m. I'm not sure why they did it that way, but just put this expression just goes right here. So it looks like the n plus first derivative exponent factorial. In fact, the other page I wrote it in, didn't I? So this works whether you have an alternating series or not alternating. You might recall e to the x was not alternating, then you would have to do this thing. Okay, so in my analysis, I put this absolute value right here in place of m, and I try to maximize this quantity. So it looks like absolute value of f of n plus 1 of x, absolute value of x minus 8 at n plus 1 over n plus 1 factorial. You go to the n plus first derivative, x1 factorial, absolute value, absolute value. This one doesn't need an absolute value because it's already positive no matter what. So there we go. Okay. All right, and I was going to stop there, folks. I have more problems that I can do, but I'm going to save it for Monday and Tuesday. We're good. Besides, I have to process the video within the next 10 minutes before my computer shuts down. So I have to stop anyway. Okay, so let me stop the share. Check the chat. Anybody have a question, please? All right, have a good weekend. Get going on the quiz, and we'll see you next time. Okay, all right, bye, everybody.
Thank you.